Let's try some. For the functions, f of x is x squared minus 4, and g of x is 3x plus 1 over x squared minus 25. Find. We're going to have everyone come to the board? I'm kidding. Oh, that got your heart going. You're welcome. Oh my gosh. I don't want to move. So since our function f is x squared minus 4, then the first three here, we're only dealing with f. We don't deal with g until the next line there. So f of 0 says, instead of that x, you put in 0. What is 0 squared minus 4? Negative 4. So as an ordered pair, what does this look like? 0 comma negative 4. Good. So if we were to graph this function, then we would have the ordered pair 0 comma negative 4. So f of 3, just like the previous one, we are going to put in 3 in for x. What do we get? Is 5. So 9 minus 4, correct, is 5. So that's the ordered pair 3 comma 5. And how about f of negative 2? Right. Please note the use of parentheses, because you have to square the negative and the 2. If you wrote this, that is not the same thing. So just to be clear, if you wrote that and you still got 0, that means, well, I knew what you meant to do, but you didn't write it correctly. And that will be a deduction of points, because I don't care about the answer, I care about the process. So please make sure you have parentheses there. 0. Great. Now before continuing further with D, E, and F, let's talk about what just happened in part A and in part C. For a function, and we're going to say this later on, but this is just a preview of coming attractions. For a function, notice the number 0 gave us the number negative 4. When your x value is 0, then that point on the graph is a y-intercept. So we found the y-intercept of the graph. In layman's terms, that's the point where the function crosses the y-axis. How many y-intercepts can a function have? 1. Why? There you go. Because 1x can only go to 1y. If we had 2 y-intercepts, then that x is related to 2 y's. And that's not good. That would not be a function. Good. Whereas over here, the number 2 made the function equal to 0. Oh, hello, previous section. It's an x-intercept. Or, what word do we have for negative 2? I wrote it over here. It's a type of beer. Root. Very good. Or a 0. So remember, a number that makes a function 0 is called a root, or it's called a 0. On the graph, it leads to an x-intercept. All right, die. Let's talk about die. To do D, this would be x plus h squared and then minus 4. So, let's talk about what happened. This x here is not this x here. They are not the same thing. This notation says whenever you see an x, you're going to replace it with x plus 4. Just like whenever you saw an x, you put in a 3. Just like whenever you saw an x, you plugged in a negative 2. So, because this x now becomes x plus h, we get the quantity x plus h squared minus 4. So that's hurdle number 1. Hurdle number 2. X plus h is how many terms? 2. And so we're squaring something that has 2 terms. What do you have to do? FOIL. If you FOILed, what does first give you? Outer? Well, that's going to be the final result, but that's fine. So XH, then inner is another XH or HX, it doesn't matter. And then last? Good. And don't lose that -4, it still sticks around. So how many XHs do we have? 2. That's your final answer. So the second hurdle is sometimes students write x plus h quantity squared is x squared plus h squared. Don't do that. How many points do you get? 0. Because that is a terrible, terrible thing to do. It's like hugging a kitten too hard. Don't do that. E. G of 5. Well, now since it's g of 5, that means we put the number 5 in for these x's, because that's the function g. So we'd have 3 times 5 plus 1 over 5 squared minus 25. What is 3 times 5 plus 1? 16 over 5 squared minus 25? What is 16 divided by 0? Undefined. Does not exist. You can't do it. Okay, F. What's F of 1? One squared minus 4. That's F of 1. Plus G of 6. 3 times 6 plus 1 over 6 squared minus 25. So notice the function, or the problem is telling you what function to use. F of 1, you go to function F, plug in 1. G of 6, you go to function G, plug in 6. Oh, I should have used different colors, that's okay. So F of 1 cleans up to be what, -3? Plus, I don't know, 19 over, 11. Oh, we need a common denominator here. Let's see, so that'd be -33 over 11 plus 19 over 11. What does that give you? -14 over 11? Since this did not come from one function, we cannot write it as an ordered pair. We have to just keep it as it is.